A deforming mesh sequence is a mesh with fixed connectivity but changing vertex positions. Each frame is given as a separate mesh. These sequences are redundant, discrete, and difficult to edit. We propose a continuous and editable representation for mesh sequences using 3 separate signals for time, pose, and shape. This application shows our representation in action. On the left is the pose space, where the time signal is shown as a curve. We get the shape on the right by evaluating our pose signal at the marked red point. When we view this sequence using our representation, the red evaluation point moves along the time signal on the left, and we recover the frames of the original sequence on the right. Because our representation is continuous, we can evaluate the time signal at any location, not just at the original frames. We can also evaluate the pose signal wherever we like. The pose signal is a smooth surface of shapes, so smooth movement in the pose space gives smooth changes in the mesh. We can use the flexibility of this representation to edit and reuse deforming mesh sequences in a variety of ways. By replacing the shape signal but keeping the time and pose signals, we can transfer the horse's gallop to this elephant. Our representation stays continuous, so we can still evaluate the time and pose signals at arbitrary locations. Here we show our representation applied to a different animation. We can edit the sequence by modifying the control points of the time signal. Here we add a loop to the time signal curve, edit the control points to get the desired result, and then view the resulting sequence. The new frames blend smoothly with the rest of the mesh sequence. This sequence shows an elastic cow under the action of gravity and external forces. There are frames in this sequence where the cow's legs become thin, but these appear in the original sequence. They are not artifacts of our representation. Instead of editing the time signal curve, we can also edit the time signal by changing the sampling rate. Here we sample the time signal to slow down some parts of the sequence and speed up others. Changing the sampling rate allows arbitrary slow and fast motion effects, as well as frame rate conversion. We can also use our representation to create new deforming mesh sequences using existing static shapes. Here we create a pose signal by positioning 9 facial expressions in pose space. We have also created a time signal, the curve shown on the left. Playing the sequence evaluates the time signal to show a new deforming mesh sequence with smooth transitions. To find a pose signal, we need a position for each frame in pose space. We can find these positions automatically, but we also need the ability to make manual corrections. For this sequence, here is the automatic layout of frames. These 4 frames on the left are positioned so that the time signal intersects, although they correspond to very different parts of the sequence. Although the discrete frames are still reproduced, this gives an unnatural transition as we move from one frame to another in pose space. We address this problem by adding user constraints to the positioning algorithm. Here the user adds positioning constraints to remove the unwanted intersections. Multidimensional scaling is used to adapt the rest of the frames in response to the constraints. The resulting pose signal has a much better transition between these 2 adjacent frames. This representation is now ready for editing. Our representation is not limited to a particular type of dynamic geometry. Here we show a reconstruction of a simulated billowing flag. We can add new frames without the cost of a new cloth simulation. In summary, we believe this is the first system that allows discrete mesh sequences to be handled in a continuous way, with a wide variety of editing applications. Thank you for watching.